Welcome to the Deep Dive. Today, we're diving deep into, well, the electrifying, really rapidly evolving world of AI.
Very.
Our mission, to unpack the very latest developments and sort of reveal how they're transforming not just entire industries, but maybe potentially your personal life in ways we're only just beginning to grasp.
Yeah, absolutely. Consider this your fast track to understanding what's truly groundbreaking in AI right now. It should help you get informed quickly and thoroughly.
It's really astounding how fast AI is advancing. I mean, the source material even notes that lectures on this topic, once just updated, already need heavy revisions. That's just the pace of change we're talking about, isn't it?
It absolutely is. We are in a truly significant moment. When you think back on other transformative technologies, like the internet, then cell phones, or later the iPhone, this current wave of AI feels exactly the same. We're maybe only a couple of years into really grasping its full implications, much like we were, say, 2 or 3 years into those earlier tech revolutions. This feeling of like everything shifting so suddenly is incredibly palpable right now.
Yeah, and some pivotal players have really shaped this shift, haven't they? You think about OpenAI, which, I mean, undeniably created that watershed moment when we all realized the immense power of generative AI. Then came Copilot, right? Where Microsoft made that significant investment to kind of mainstream it, embedding AI capabilities everywhere. It's really remarkable how swiftly generative AI expanded its use cases, moving from the obvious fits like assessing creditworthiness to these unexpected areas like fashion product selection. That was unthinkable just a few years back.
Oh, completely. But what's most striking here, I think, is the pivotal disruption brought on by DeepSeek. Because up until that point, the prevailing assumption was that cutting-edge AI needed these massive, prohibitively expensive cloud servers.
Right. Big data centers.
Exactly. Then DeepSeek just emerged with this revolutionary idea.
Yeah.
You could actually download these huge AI knowledge bases onto your personal computer. That was jarring. A complete paradigm shift.
Really? Onto a normal PC?
Well, a powerful one, but yes, suddenly a relatively affordable computer could run a full AI model locally. It just eliminated the need to connect to some massive data center somewhere across the globe. And that realization really spurred other major AI companies to start releasing their own more accessible models too.
Wow. Okay, so that's the incredible landscape of AI right now, this huge shift driven by players like OpenAI and DeepSeek. But all this modern AI, all this magic, it hinges on a fundamental yet often unseen technology. So I think it's time we pulled back the curtain a bit on vector databases. Now, don't let the name intimidate you. We're about to make it crystal clear why they're basically the engine of today's AI.
Precisely, yeah. While traditional relational databases, as you know, they excel at organizing structured business data tables, columns, rows, that kind of thing.
Customer records, sales figures.
Exactly. Vector databases operate on a fundamentally different principle. They're purpose-built for the complex, unstructured data AI thrives on. Text, images, audio. This is where AI truly lives, you could say, in terms of its data.
Okay, so how do they actually organize this incredibly complex data in a way that, well, makes sense to an AI? How does that work?
That's a great question. So in a vector database, what's kind of analogous to a table in a relational database is called a vector space. So you might have a music vector space, or maybe a cat vector space, or a tree vector space. Basically a dedicated area for that specific type of information.
Okay.
And when you put data into one of these, it's called embedding, which is far more sophisticated than just a simple insert operation. It actually involves building complex relationships and associations between different pieces of data as it's added.
Right, so it's learning as it goes in.
In a sense, yes.
Yeah.
The data itself is represented as a vector, which is just a fancy word for a digital representation of that text, audio, or image as a string of numbers. Lots of numbers. Now imagine a vector as a coordinate point in this vast, multidimensional digital space. Yeah, each point has dimensions. Think of them like different traits or attributes describing that piece of data. So for a song, dimensions might represent its tempo, its key, instrumentation, maybe even its mood. For an image, it could be color, texture, shape, the objects within it. And the AI uses these dimensions to understand and organize all this complex information.
Okay, I think I'm following. And you mentioned parameters. You said that was really important.
Yes, parameters are arguably the single most important concept here. Think of them as the AI's cumulative knowledge, basically. It's the number of neural connections and learned relationships it holds inside. So when you hear about an AI with, say, 700 billion parameters, that's its true scale of intelligence or knowledge, much, much larger than one with maybe 14 billion. It's kind of how we measure how smart or maybe how knowledgeable an AI truly is. It's constantly refined through training, getting better at recognizing things.
Like a car getting more certain about identifying an object.
Exactly. It might go from 80% certainty it's a pedestrian to 95% certainty through more training, refining those parameters.
Okay. So this grouping of similarities you mentioned, how does it actually figure out those patterns in practice?
Well, it looks for inherent patterns in the data, in those numbers. If you're embedding music, for example, it might group Metallica, Slayer, and Anthrax together because of, I don't know, similar drum beats or bass lines, or maybe it's just the overall intensity.
Right, the heavy metal group.
Yeah. Then you might have another group with, say, the Eagles and Dire Straits. And then completely elsewhere, Peter, Paul, and Mary, very different sound profiles.
Yeah.
It uses these similarities, these groupings, to enable powerful recommendation algorithms. It's much like how Netflix suggests your next show, or Spotify recommends your next song.
Ah, okay, so it's the same underlying idea.
It's the same underlying principle, yeah, just supercharged for AI and working across different types of data. And for images, it's actually quite ingenious. When AI processes an image, like a cat, it essentially breaks it down. It deconstructs it into its constituent features, identifying contours, textures, specific elements like ears or whiskers.
Little boxes almost.
Kind of, yeah. It then converts these visual characteristics into numerical representations, into vectors. And think about this. Social media companies have, maybe inadvertently, trained massive image databases for years. Every time users upload selfies from places like the Eiffel Tower, they're providing, well, every kind of permutation of that landmark.
Different lighting, weather, angles.
Exactly. All that diverse data helps the AI identify it reliably, no matter the conditions. It learns what Eiffel Tower looks like from thousands of examples.
That makes sense.
Now, this all sounds deceptively straightforward, but it involves immense mathematical complexity. Really heavy math. To handle the long data streams of pixels from an image or a video, you need incredibly powerful GPUs, those graphics processing units.
Gaming cards, right.
That's often where they come from, yes.
Yeah.
Because at its core, AI operations are nothing but numbers, crunching huge amounts of numbers very, very quickly. And here's the crucial point. The entire vector database, with all those numbers and relationships, it needs to be loaded directly into memory, into RAM, for the AI to actually function.
Not off the hard drive.
No, not off a hard drive. It's all got to be in active memory, which is why having sufficient RAM is absolutely critical for running these models locally.
Okay, so given the sheer processing power, and especially the memory you've just described these models needing, it still sounds like only massive, expensive cloud servers could possibly run them. Is that really the case, or is there actually a surprising path for someone, listening right now to bring this kind of AI power home?
And the AI model itself.
Right. For the AI model, I went with Microsoft's Phi 4. It's about 9.1 gigabytes and has 14 billion parameters. It's basically a subset of GPT, includes all the necessary language and audio components you'd need. And the reason I chose it was because it fits comfortably in that 64 gigabytes of RAM.
Unlike some of the bigger ones? Yep. Exactly. Unlike, say, DeepSeek's model, which is huge, 404 gigabytes with 671 billion parameters,
Right.
or even Meta's Llama 3.2, which is still pretty big at 55 gigs and 90 billion parameters. You'd need way more RAM for those.
Got it.
And then finally, for the chat interface, I use a tool called Anything LLM. Again, free. And it can communicate with over 1,700 different vector database models. And for voice input, Whisper Web, another free voice recognition tool.
So if I'm understanding this correctly, then these models are essentially plug and play, almost like old cassette tapes or MP3s. You can just swap out different AI models from different vendors depending on what you need at that moment. That capability is truly astounding.
Exactly. That's the beauty of it. It opens up a whole world of possibilities.
Yeah.
Because you're not locked into one specific cloud provider or ecosystem. You can try different models, you can delete them, store them offline, bring them back whenever you need. It's incredibly flexible.
Mm-hmm.
It also beautifully writes code, though, like HTML.
Yeah.
And it can even scrape public websites to generate new ones based on that data. But here's where it gets particularly compelling, I think. The potential for private training data.
Feeding it your own stuff.
Precisely. Instead of relying solely on that vast, publicly scraped data from cloud providers, you can feed your own unique information into your local vector database. Think about it. Your own Python programs, all your PDFs, your business case studies, even transcribed recordings of, say, your old lectures, or your entire archive of Word documents from the last 20 years.
Wow.
You can create these custom, highly personalized knowledge bases. Imagine having a vector database preloaded with everything for a specific class you teach, or even a personal archive that you can just talk to. Like, hey, give me the summary of this specific case study from 2018, or explain this concept using the examples I used in my lecture last Tuesday.
That's a monumental shift. It really transforms AI from this kind of abstract, distant cloud thing into something really tangible and personal.
Okay, so let's turn our attention now to the AI you might not even realize is kind of humming away around you every single day.
Yeah.
Can you give us some concrete examples that connect directly to, our daily lives?
Oh, definitely. What's striking is just how pervasive AI already is, often invisibly. Take highway cameras, for instance. Contrary to what some people might think, it's generally not people sitting there watching a wall of monitors 24/7.
Right.
It's AI, identifying objects like cars and trucks, measuring traffic volume in real time, and even connecting different cameras for crime tracking or identifying speeding vehicles automatically.
Okay, traffic monitoring. What else?
Well, in agriculture and wildlife management, you've got drones using AI. They can count herds, like spotting if a cow is missing on a huge ranch, or for inventorying wildlife populations. And then there's retail and hospitality. Starbucks is a known example.
Starbucks. How are they using it? They use advanced cameras, combined with AI, to track things like customer dwell time at tables, how long people stay. They monitor barista productivity. And they even analyze friction points in workflows, like figuring out if moving the cups slightly closer would optimize the service flow and speed things up.
Huh. Analyzing workflows. Interesting.
And when we expand this to a broader scope, think about shopping malls. They widely use cameras, often with facial recognition capabilities.
Facial recognition in malls.
Oh, yes. To track individual customer behavior. Which stores you visit, where you stop for lunch, even where you park your car. All this data helps them optimize store layouts based on actual foot traffic patterns. Where should the anchor stores be? Where do people linger? And of course, social media platforms heavily use AI to group users into vector spaces based on your content, your clicks, your behavior, all for highly targeted advertising.
Right, the ads that follow you around.
That's part of it. And then you get into city surveillance. Larger cities like London, Beijing, and even some American cities employ pretty high-level AI monitoring through cameras, sometimes hidden in plain sight, like on church steeples. These systems identify potentially hazardous zones, monitor traffic flow across the city, and yes, track individuals using facial recognition.
Wow. Okay. That's quite a lot of monitoring.
It is. And even in food service, you might encounter AI systems in drive-thrus now. They can take your order in, supposedly, any language and any accent.
I think I've heard about those.
Yeah. And for content creation, this is fascinating. AI can now create these TED Talk-like avatars from just your image, your voice, and a text script you provide. It makes delivering content potentially much more engaging, or at least scalable. There are even professional services popping up that can build your personal avatar from just an hour or so of green screen footage.
A digital twin, almost.
Sort of, yeah. A presentational avatar.
Okay, the sheer pervasiveness of AI, I mean, from traffic lights to tailored ads to analyzing coffee shop workflows, it's truly remarkable. And yet, what we've discussed so far, it feels like it only scratches the surface, doesn't it? This ability to build personalized AI. And now these digital avatars, it just opens up entirely new frontiers. What then are the most profound and perhaps even, well, mind-bending implications of this technology as you see it?
Well, it does raise a really important question, I think. If we can create these self-contained, individualized vector databases, what's really stopping us from filling them with a complete knowledge of historical figures?
Like talking to Einstein.
Exactly. Imagine having a direct conversation with, say, Albert Einstein about the theory of relativity. The AI could pull context and answers from all his digitized writings, photos, maybe even synthesized voice recordings based on actual samples. Or interacting with avatars of Thomas Edison or Abraham Lincoln, complete with their digitized writings, images, maybe even synthesized voices that sound like them. And this could extend theoretically to anyone important to you, allowing future generations to engage with their digitized legacy.
A way to preserve personality, almost.
Perhaps.
Yeah.
And think about the connection to robots. If AI like 5.4 can run effectively on a desktop.
Then it can run inside a robot.
Precisely. This means hour-long, genuinely personal conversations with humanoid robots could become commonplace, offering companionship maybe for, say, a 95-year-old parent living alone.
That's a huge potential application.
It is. And Meta, for example, is reportedly very interested in retaining vast amounts of user social media data, possibly with the long-term goal of creating interactive avatars of individuals for future generations. Imagine, your grandkids interacting with an AI avatar of you, based on your posts, your photos, your interactions over decades.
That's slightly unnerving, but also fascinating, the legacy concept.
It really is. And this also brings up the whole idea of qualified knowledge versus just the broadly scraped data found in large public AI models. We're starting to see unique AI interfaces emerge, like Grok, for instance. It doesn't just answer your question, it then asks you personal follow-up questions to delve deeper, to understand your context.
More like a real conversation.
Exactly. It hints at a future where AI interactions are far more like genuine back-and-forth conversations than just simple Q&A sessions. More context-aware, more personalized.
Hmm. That's a really powerful thought to leave us with the idea of creating a living, interactive legacy or just having a much deeper conversation with AI. So it makes you wonder, what kind of personal AI would you want to build for yourself or maybe even for a loved one? Using these new capabilities, what would it know? How would you want to interact with it? Something to think about. Today, we've taken a really deep dive into this profound shift towards personalized local AI and seen just how pervasive its real-world applications already are. We've journeyed from, massive cloud servers down to building your own AI for potentially just $100, and we've gone from basic data analysis to AI that can mimic historical figures or optimize a city's traffic flow. We truly hope this deep dive has, well, maybe transformed your understanding of AI and its potential impact on your life.
Yeah, the rapid pace of change in this field is just astounding, isn't it? And the possibilities ahead are truly exciting. We're really only just beginning to see how deeply integrated AI will become in our lives, from the really visible applications to the ones quietly operating in the background. So, yeah, keep exploring, keep questioning, and definitely keep an eye on this dynamic field. There's so much more to come.